Statistical Process Control, or SPC, is a powerful tool used in quality management to help identify issues and maintain a controlled process. Do you know everything you need to know to maximize your CPK? SPC has its roots in the early 20th century when the Industrial Revolution led to mass production and the subsequent need to control product quality. A man named Walter Shewhart is credited with the development of the concepts behind SPC, and other contributors over the years have improved on various aspects, like the managerial aspects of SPC. One of the key concepts behind SPC is the understanding of process variation. When we say variation, we're referring to the fluctuations that we observe in a process over time. We divide the fluctuations we observe into two general categories: common cause, which are those variations that are natural and result from everyday factors that affect the process that are generally stable and predictable. These are things like machine vibration or minor changes in material properties. The second is called special cause variation, which arises from special sources not normal to the process and can indicate there's a problem. Things like machine malfunction or operator error are examples of special cause. The idea behind SPC is that we can use control charts, which we'll talk about in a second, to monitor the performance of our process and use the observed fluctuations that we see as indicators to identify and fix special cause of the variation to eventually eliminate them. There are many types of control charts used depending on your sample size and process specifics. Common examples are either I charts or X bar charts, depending on if samples are grouped into subgroups. These charts plot the individual or average values of a subgroup over time. Control limits are plotted, which indicate a statistical quantity representing the capability of the process. Many in the industry agree to use 3 sigma, or 3 times the standard deviation of the data above and below the process mean, as a standard control limit. Other types of control charts are range charts, which plot the range of the data, and an S chart, which plots the standard deviation of subgroups over time. So using the SPC process would look something like this. You run your process and collect data on a process variable like widget size or shape, and then monitor it over time. If you see trends in the data, they can indicate special cause of the variation that need to be removed. Statistical tools like fishbone diagrams, Pareto charts, flow diagrams, and scatter plots are then used to model the process and eventually identify the root cause of an issue. That issue is then addressed. Once a process is stable and within control limits, a process indicator like CPK is calculated to quantify the capability of the process. Alright, if you like this content, make sure to hit the like button and subscribe. Now, although the big picture of SPC is fairly simple, actually doing some of these things can be complicated. If you have any questions about SPC or the details of control charts, statistical tools, or anything else, make sure to leave them in the comments below, or you can send an email to AskDrAdam@KYZEN.com. Thanks again, and stay clean.